So welcome to this demonstration of the DataViadotto Entity Relationship Profiler. My name is Sebastian. So essentially we want to demonstrate our capabilities of mining keys and inclusion dependencies from given data sources. As use case, we are taking a publicly available hockey database from this repository here. The first step would be to connect. We've done this already, and then we would sample. So therefore, we fetch the schemas available. We look for the hockey database, and then we sample. So there's 22 tables altogether, approximately 300,000 rows with 300 columns, 15.6 megabytes. So we select all of those, then we press sample, and that actually ensures row scalability. In this example, the size is small enough not to remove any records, so we get exact results. Otherwise, if you have large databases, of course, then you need to sample to ensure row scalability, and we do this in new advanced ways. We then can explore the samples. They are available. There's some metadata like null counts and distinct counts available. But we move on to the more interesting bits where we can set parameters for finding keys and relationships. So in particular, the problems W2 and W3 complete in the arity. So that means it's highly intractable, even for fixed numbers of fields and sequences of fields. So therefore, it makes sense to set the parameter here accordingly. So here we can then select the samples. And we pick all of them. So that means we're looking for all keys up to arity 3 in all the 22 tables. So this is done extremely quickly. And we could then, for example, download those keys and actually restrict the search of foreign keys to reference the uniqueness constraints that we have in mind. So we can click here on the mine keys and set those, and then the search is restricted. And now we can also set thresholds here differently. So let's say we pick 90 to accommodate some dirty data in there. And then again, we select the samples. And here now we want to mine foreign keys between all pairs of these 22 tables available. And then we click on find relationships, and then the mining algorithm starts, and it's done extremely quickly. We found 35 relationships within 1 second. And then we can browse the keys and relationships. So you can see the minimal keys in here. And what is interesting is actually the interaction that we facilitate with the data sets. So you can see here data samples taken from the database that actually illustrate that this is a minimal key available, and that is how you can check actually the sensibility of the keys and the foreign keys available. Similarly, that works well for relationships, and then we could look for particular examples we are interested in. So for example, the teams versus teams to the teams table in here says that every team that plays one another must actually be a team that's registered. So here we have the team ID and the opponent ID. And then this holds with these thresholds, but also we can see here the best available join type for this, which is actually an inner join for a many-to-one relationship. So this is really useful information that we make available here for users. And again, you can then highlight the sensibility of the keys by looking at data samples. So we could look, for example, for serious posts, which is interesting. And here is actually a foreign key that only holds with 99%. But it is a sensible key because it says serious post is basically a game in a playoff, and this references a team's post table. So for teams that actually made it to the playoffs, and this is a very sensible foreign key that was not specified on the original schema. And there are several use cases like this. And then if we click on the data in here, we can actually see that there are violations. So these are violations of referential integrity. So automatically we also find data quality problems. So for the use case, we will take the users through this experience and actually identify problems with the original database schema through the use of our tool.